Okay, so it is 7. I have to work at 9. I may not work on this right up until 9 o'clock, but maybe I will. So what I have on the docket here is I have my approximate gradient function, and I need to implement gradient descent, and then I need to find a good solution in the solution space. Yeah. Now, I had a thought last night during the many hours where I was trying to sleep, and I thought about how what we're doing in this function is we try, so this is too small. This is annoying. Okay. So we try a couple of points on the function. Now, let's say, this is a bad example, so I'm just going to pick a different example first, and then we can talk about this. But let's say that we were at this point. Actually, no, let's say we were at this point, and we wanted to find the local min. Well, if we're already computing these 2 points in either end, why not just fit, a curve and find the minimum of that curve? I think it should work. The downside is that, well, okay, I mean, in this particular case, I just happened to draw a point on a local max. So here, I guess we would just fail to converge. Or we would just pick an arbitrary direction. I don't know. But it should work. I kind of want to try that first. So here I want to do is do gradient and next. Right, and so now here what I'm going to do so if type of next of I is equal to undefined, try using VL and VR to fit a quadratic and find the minimum of that quadratic. As a sanity check, we will see if the function value is actually smaller. If not, we will just return x unchanged. Or oh, actually, if not, we will pick the x corresponding to VL or VR, whichever is smallest. Okay, so how do we do this? So if I have, let's say I have 3 points that look like this. Actually, we can do a little better because we know they're evenly spaced. So let's say they look like this. And we know that this distance is the same as that distance, which is h. And we want to fit the curve that goes through like that. Except it'll touch all these points, but you get the idea. So, I gotta do a little calculus here. So, suppose f of x, or let's say q for quadratic of x, is equal to ax squared plus bx plus c. Then q of x plus h is equal to f at x plus h times x, the first derivative of q at x, so that is 2ax plus b, and plus h squared over 2, well, I guess I'll write it like this, times h squared times the second derivative, which is just 2a. And then what we can do is q, of x minus h so this is our x. Well, maybe x0. Whatever, it's fine. And then here, this is going to be minus h times that, and then here the h gets squared, so the minuses cancel out. So if I add up these two equations, then I get q of x naught plus h minus q of x naught minus h equals actually I want to add these two together. So this is 2 q of x naught, which we have, we know that, plus h squared times 2a. In other words, a is equal to q of x naught plus h plus q of x naught minus h minus 2q of x naught over 2 times h squared. Right? And then if we subtract these two equations, q of x naught plus h minus q of x naught minus h is equal to 2h times 2a x naught plus b, which means that b is equal to q of x naught plus h. You know what? I'm just gonna let QL equals q of x naught plus h, minus h, and QR equals q of x naught plus h. So this is going to become QL plus QR, and I'm just going to call it Q naught. I think you get the idea. Equals that. Okay. Then here we have QL plus QR minus 2Q naught over 2h squared ooh. Okay, I'll just redraw that. Okay. Now QR minus QL is equal to 2h times all that. So B is equal to QR minus QL over 2h minus 2a times x naught. Okay. And now the minimum of this function minimum of q is equal to, or let's actually, it's min of q. So if a is less than 0, then the minimum of q is equal to minus b over 2a. Everybody knows that. The minimum over x. Let me just, the derivative of that is 2ax plus b, yeah, minus b over 2a. So finally, if we plug in all of that stuff, we get equals negative b, which is ql minus qr over 2h plus 2a times x naught, and then all of that over 2a this gets multiplied by an h squared, and then in the denominator we have ql plus qr minus 2q naught. It's probably a slick way to do the algebra on this, but you know. Oops. And let's see. We can move this 2h into the denominator is equal to ql minus qr plus 4 times h times a. Oh wait, where did this a come from? Oh. Okay, we gotta fix that, so, which is equal to, need more space. So if I plug in this expression for a, one of these 2's goes away, one of these h's goes away. So what we get is two times shoot. Man, this is pretty ugly. I mean, we do also have Q0 at our disposal. So, actually, why would we bother to do that when we can just do QR minus Q0? That doesn't work either. Minus QL. I guess there's no choice but to just plug it in here, so let's just go ahead and do that. So I guess one of these 2's goes away, at least. And all that is divided by h squared, and we still have the plus b. Right? So 2 times a. So let me just do this. Right? And hold on, before I go any further here, like this is still correct to say it's 2a. It just so happens. So if b is equal to that, minus b over 2a oh yeah, okay. I see one way I can simplify this actually. So then we can just, so minus b over 2a is this divided by, so negative that divided by the expression for 2a, which we'll plug in, minus x naught, right? Because if I divide this by 2a, the 2a goes away. So minus x naught. Yeah. So let's do that. So that is QR minus QL times h squared divided by QL plus QR minus 2Q naught, right? So I take this expression, oh wait, divided by 2h, I forgot this divided by 2h, so times 2h squared, right? But then, so I multiply by this and divide by that, which I did, but actually one of these 2's goes away and one of these h's goes away. And then this 2a, well, this becomes a plus 2a because it's minus b, so plus x naught. So that's interesting here. So to go from x naught to the supposed minimum of this quadratic that we fit, we add h times this expression. Let's just try this out here. So let's just do a test and make sure that this algebra is correct. Use, I don't know, x squared minus 4x around x equals 0 with h equals 1, you know, make our lives easy. So QL is equal to negative 1 squared minus 4 times negative 1. So that is 1 minus negative 4 is 5. Q0 is equal to 0. QR is equal to 1 squared minus 4, which is negative 3. So if I do QR minus QL, so we have negative 3 minus 5 times h, which is 1, divided by QL plus QR plus minus 3 minus 2 times 0. And then I add that to 0, I get, so that is negative 8 divided by 0. Oh no, 2 times 0, I gotta remember my order of operations. So 5 plus negative 3 is 2, which equals minus 4. And is that correct? I mean, I think it is, but let's just go ahead and use Desmos. Why not? Ooh. Well, something's wrong here. Well, first of all, that is 5. That is -3. And that is 0. So my 3 points are correct. Did I do this math correctly? In other words, did I plug in correctly? So -3 minus 5 divided by, or times h divided by 5 plus -3 minus 2 times 0. Oh, I think I'm missing a minus sign. Anyway, let's try that again there. So if I add these two equations, I get 2q naught plus h squared times 2a. That is correct. So a is equal to ql plus qr minus 2q naught over 2h squared. That much is fine. And qr minus ql is this ugly expression. 2h times 2a times x naught plus b. Therefore, b is equal to qr minus ql divided by 2h minus 2ax naught. Also, this is a is greater than 0. I don't know why I said less than 0. Then the minimum x over q is -b over 2a. So -b. So this is actually ql minus qr. So I was missing a minus sign, but this is still, I think, incorrect. I'm not sure though. So ql minus qr, so 5 minus -3, which is just 8 over 2, which is still wrong. It's 4, but the real answer is 2. But this qr minus ql over 2h minus 2ax naught. So if I take all this and I divide it, I multiply by -1, and I divide by 2a, so yeah, this x naught is fine over here. I think this expression must be wrong then over here. So qr minus ql over, let's just do it all, 2h well, actually, ql minus qr over 2h, and then this is times 2h squared over ql plus qr minus 2q naught. Which equals, so we can cancel out one of these two h's. Wait, am I forgetting the 2? This is -b. Yeah, I am forgetting a 2. Over 2 times that. Right? So this is -b over 2 times a. Okay, great. So we cancel out a 2, we cancel out an h. So we get QL minus QR times H over 4 times QL plus QR minus 2 Q naught. Plus X dot. Right? So QL minus QR, 5 minus negative 3 times H, all this divided by 4 times QL plus QR minus 2Q naught, which equals 8 divided by 4 times, and this is still wrong, 4 times 5 plus negative 3 is 2 is 1. It's still wrong. You may be wondering, why am I doing this myself when someone's already done this before, almost certainly. Don't tell me what to do. It's my stream. No, I feel like it. I mean, this is the whole point of the project, is to do it on my own. Oh wait, did I canceled out a 2h, but I left a 4 in the denominator for some reason. So here, this 2h goes away, so the squared goes away, and the 2 goes away. So we're just left with the 2 in the denominator. Okay, everything's fine. Okay, so this is the final expression. Okay, so var x next is going to be equal to well, actually, just call it h next is equal to in here for my reference, is equal to VL minus VR times H divided by 2 times VL plus VR minus 2 times V0. So x plus h of I is going to be equal to x of I plus h next, right?
QL minus QR times H divided by 2 times QL plus QR minus 2 Q naught. Okay, great. Var V next is equal to F at X plus H. I don't know. Temp is equal to here we'll do next of I is equal to X plus H of I. So then let's just do VL, V0, VR. X is equal to X. Ugh, shoot. Whatever. X minus H, X, X plus H. You know what? Why bother doing that? If VL is less than V next, V next equals VL, next of I equals X minus H. Then we'll just do this for all three of them. If V0 X plus H. Is that what I called it? Yeah. And then console.log next guess t.next and console.log original value, or I guess I'll say original f at x, which is going to be vmag of 2, 3 descended f at x, or maybe I'll just do, well, whatever, that's fine. Vmag of t dot next. Let's just see what that gives us. Okay, we're ready. Nan. Well then. I guess it's possible that this is 0, but nah, how could, oh, wait a minute. Oh no, I guess this could be 0. That's right, I need to put this in a try-catch block. VL times 2. Okay, fine. There. That should solve that problem. It'd be nice if I could single step this in the debugger. Can you do that actually? Ah, that's handy. Oh, that's way better. Okay, I gotta get rid of all these print statements. I don't need those anymore. What's the shortcut? F10. So my V0 is 3.6, my Vnext is 3.1, my VL is actually smaller than my, oh no. Oh yeah, my Vnext is the best, yeah. So Vnext is the best for sure. So next to I. So V0, VL, Vnext. Oh my god, why is Vnext so big? What? Why was Hnext so big? I guess it's because we have a situation here where I think we're divided by 0 or something. Alright, well if A equals 0, or is very close to 0, okay, I think I know what to do. Yeah, I think
think I know what to do. So var close to collinear equals this. Close to collinear, and move on. Okay, so now we will do our very close to collinear is equal to discrepancy is less than 1e minus 7. What should the step be in this case? This is my issue with gradient descent, is that it's, well, how do you pick a step size? But actually, none of this matters, though. None of this matters. If very close to collinear, then I don't know. Just set h next equals VL minus VR, then minus 2 times h, otherwise 2 times h, like, whatever. Like, I don't know. Just whatever. So this is very close to collinear. Fine. Okay. It's marginally smaller. Hmm. So this method is not working. Oh, wait a minute. It's because it's very close to collinear. Oh, wait a minute. Of course it's very close to collinear. This function is linear. It's the square root, the Euclidean distance. It makes a cone, doesn't it? Alright, just for the sake of argument here. Just for the sake of argument. I mean, it's bad if your gradient descent function... Well, actually, yeah, a cone shape is like one of the worst cases for... It's not one of the worst cases for gradient descent. I mean, it's easy. If you just follow the gradient, you'll be fine. The issue is choosing the step size.
What's the actual gradient? I think it's just 2 times 2 and 2 times 3, right? Whatever, let's just see. Yeah. Yeah, there you go. Here's a thought. What if we made a rule that if it's pretty much collinear, we will just arbitrarily set A to be equal to, I don't know, 0.1 or something. You know, just so that we're not searching forever, like. So where is all that algebra? So here, if we force A to just be 0.1, then it's just this times 100. Right? Why not, right? Let's just do that. I think that works. So just 50 times QR minus QL over H. $50 times QR minus QL over H. Let's just do that. There. Let's just try that. See what happens. Also, let's comment this out. I don't need it right now. Okay, and now, what happens if I do, oh yeah. Function vmag of x, return math.squirt of vmag square of x. Okay, we'll go back here. Vmag. Shouldn't have got rid of that s. Is equal to 1 over 2 times vmag 2, 3. I think we should just multiply both of these by s. Maybe. Whoops. Okay, well, a couple of things to fix here, but okay. QR is not defined. Oh, right, it's VR.
That's what I get for using different symbol names in my scratch work versus my code. Nan? Why do we have Nan? Okay, we need to figure that out. So h next is some number. X plus h equals that. V next equals that. Oh wait, is x even defined? Ah, x of I, that's why. X of I. Alright, that should fix that. What time is it? 8:05. Now I don't understand. If I set A to 1, and I have 3 points that are close to collinear, so B, oh wait, minus B over 2A. So it's x naught plus QL minus QR. So I forgot the minus sign. Still though, oh hey, okay, that's an improvement. Yeah, okay, great. So, let's see. Function gradient descent f x. I don't know. Var iterations equals 10. So var x next is equal to approx grad of f at x dot next. So while iterations is greater than 0, or while iterations goes to 0, do that. Calculate x next. Now let's just do if the square distance between x and x next is less than, I don't know, 1 minus 5. Then break. Do x equals x next. And return x. Right? console.log descent test gradient descent of start it at, I don't know, 2, 3. And let's just do return vmag. Let's try square because it seems harder. Okay, so we will do just some random function. Doesn't really matter which. Also, let's comment out that debugger call. Oh, it is commented out. And also, let's put a debugger call in here. Great. Go. Okay. X next is equal to, oh my god. It immediately zeroed in on the minimum. Alright, well, let's just do a different test. That's maybe a little better. So let's put this at 0, 0. And how can we make this more interesting? Whatever. It's interesting enough. Dude, what the heck? How is it zeroing in on it so good? Oh, because I'm using vmag square, which is really easy for it to deal with. Interesting. Well, let's just do vmag then, which is a lot harder for it to deal with. Okay. Okay. So it does a step, and it's like, oh, we're not ready yet. It does another step. Ooh, we're not ready yet. It does another step. Ooh, we're not ready yet. Another step. It hasn't overshot it, but overshot it in one dimension, but not the other. And now it's bouncing because it doesn't know what to do. Oh, wait. Shoot. I wasn't paying attention and it went past the end. So yeah, here. So now here, the Y barely changed at all. It just moved by a little tiny H. Yeah. Man, picking a step size is really hard. All right, okay. Here's what we'll do. Let's add in a learning rate. Um, at least something we can configure. So, if type of LR is undefined, then we'll just do LR equals 1, right? Minus LR times H and plus LR times H. But it might not be defined at that point. All right, we need a better way to pick the step size. Well, another idea though is we could make this a tighter tolerance. Just see what happens if we do that. You know, let's make this 16. I mean, it's not a pathological function, but it's close to it. Dude, those Y steps are just tiny. The X has managed to zero in, but the Y is really far away. What happens if we keep going? Maybe we'll get lucky. No. It's just making these tiny little steps. Well, I don't have a clean or elegant idea for what to do about this. Like, my first idea of just arbitrarily multiplying it by a learning rate is kind of okay, but I don't want to return a guess vector that could possibly be outside of the domain of the function. So my first idea is, okay, well, let's take in a learning rate, we'll multiply the step size by the learning rate when we're returning our guess, but right before we do that, we'll actually test the function and see if it exists there. Or our initial step size could be a function of x. Alright, that's easy enough to implement, and it kind of makes sense anyway. So, yeah, this is a zero comparison tolerance. Actually, we can just leave that as is. Well, no. Okay. Is there a math.min? Okay, good. Math.min of 1e minus 3, or x times x of I math.abs. Actually, do I care about the abs? I don't think I do. Oh, yeah, I do, yeah, because I need the math.min there. Math.abs of x of I times, I don't know, 1e minus 2 var tall is equal to math.min of tall, or math.abs x of I times 1e minus 5. I mean, all these values are just Padumas. Let's just see what happens if we do that. Undefined. Why is that undefined? Okay, hold on. Do that again. Wait, why is age 0? Why is tolerance 0? Oh, well, I guess I do need the maximum. Although, oh yeah, okay, fine. Fine. Duh. I always get max and min. You see, whenever I write these functions myself, I always call it greater of and lesser of. Because then I never get confused. Yeah. Let's try that. It should be a little better. Okay. So eventually we should get to that spot. Well, it seems to have better performance. We are zeroing in on, you know, the real. Sorry, I just got startled. My door doesn't latch for whatever reason, and there was a bit of air pressure, and it popped the door open, and I just got startled.
Crutches are here? Okay, cool.
Oh shit, sorry, yeah.
No worries.
Here, hold on, I better come talk to them.
Oh, no, sorry, I was just starting to work,
Thanks, I'll see you around.
yeah. Me neither. I don't know. I was gonna like argue with him and start being like, I mean, I was literally fucking close to the edge. Literally can't go to work if I want to. But I was like, I'm never gonna see this guy again.
Oh, so you're not working today?
I am.
Oh, you
But
are?
I'm just working from home, yeah.
Oh.
Strike isn't happening until next week. But I think I'm going to be participating in it. I'm not gonna be happy, but I will do it.
Oh, wait. I just realized. I was doing the live stream while I was coding. I forgot to turn it off. Let me go do that. I gotta go. Not like anyone ever watches these anyway.